Hey, so in today's video, we want to talk about state machines. State machine is really famous in LabView, and a lot of users they use a state machine. So, what is a state machine? Developers they use a state machine in applications where distinguishable states exist. Each state can lead to one or multiple states and can end the process flow. A state machine relies on user input or in-state calculation to determine which state to go next. Many applications require an initialized state followed by a default state where you can perform many different actions. These actions depend on previous and current inputs as well as the states. So assume that when you're running a program, a LabVIEW program, LabVIEW waits for a user to do something, and based on the user, whatever the user did, LabVIEW will decide what to do next. That's called a state machine. You cannot uh, you can program it with case structures and sequences of cases and all these things, but it's going to get really complicated, and it's not a proper way to do it because you have to define everything for it in your program. But state machine basically it defines different states that a program can be in, and then tell the program to go to the specific state based on whatever user did. So it basically creates states and make decision making for LabVIEW easier because it will look what states it is in, and based on the user, whatever user does, it will change the next state, and it will not change it will actually choose the next stage or the next state. So that is called a state machine, and there's a way that you can program a state machine in LabVIEW. It's always nice that you draw a diagram of your problem, and that's called a state diagram. When you are designing state machines, you can create a state diagram to graphically represent the different states that you are in and how to interact with it. So I will go with an example because I always think examples are easier to follow. Imagine that we have a vending machine that accepts combination of nickels and dimes to give you a Coke. The cost of a Coke is 15 cents, and the machine does not return any changes. Here are the states that the vending machine might be in. The initial start stage that no money has been inserted in it yet, and then you can have 5 cents in it, 10 cents in it, or 15 cents in it. So when you are in the initial stage, this is called a state diagram. You can add a nickel and have 5 cents, add another nickel and have 10 cents, and have another nickel and have 15 cents. Or you can add a dime and a nickel, or a nickel and a dime, or you can have like 2 dimes, but you will not get 5 cents back. So this is called like the state diagram. It's useful for your project if you want to work with state machine to draw a state diagram so you don't miss anything. And here all these 4 states, the start, 5 cent, 10 cent, and done, or the dispense state, they are all called the states, different states that the program can be. And depending on a user when they are in a vending machine, or basically if they are in the front panel, whether they click on nickel 2 or 3 times or on a dime 1 or 2 times. So it just depends like how many times they add the nickel and dime, they can go to different states. So now let's program this in LabVIEW with state machine. Yeah, first add some buttons for nickel and dime. So right click in the front panel, go to Boolean and choose the OK button. Rename the OK button to like nickel, and also rename it for both for the label and the button itself. And I personally like to select it, right click, go to visible item and delete the label. So it's just, for me, it only looks like a button. And then I can make it large. Let's do the same thing. Go to Boolean, OK button, and this time we are having a dime. I want to select this, right click visible items and move the label. I want this to be the same size of this, so I'll just select all of them, come here and choose this, and I can then um, yeah, align them like this. I like it this way. And then right click again and go to the string and define a string indicator and call it money inserted, like how much, if you have inserted 0, 5, 10 or 15. And then in the front panel again, go to Boolean and choose an LED and say dispense. Should we dispense it or not? And I need to make this larger too. Just I like it this way. So you have created some buttons and some indicators to just show you what you're doing, but you haven't programmed it yet. So I'm gonna move them above. Whenever you want to make a state machine, that's a default. You need a while loop, a case structure, a shift register, and a case selector. So let's go ahead and add all these things. First, a while loop. So you first need to have a while loop. The next thing you need to have is you need to add a case structure inside the while loop. That's the default. I mean, you guys, we have to have that for a state machine. And then you need to have a shift register. So you go to the while loop, click on it, and add a shift register. You also need a case selector. So you go outside, right click, go to numeric, and choose enum constant. And then select your enum constant, right click on it and say edit items. So now you can define different states that your program can be in. So our program can be in a start state. We can have 5 cents in it. We can have a 10 cents state, or we can have a dispense state. Now we have our while loop, our case structure, a shift register, and a case selector. The second, the other thing that you have a state machine is that you have to connect this case selector to your shift register and your shift register to the question mark in the case selector in your case structure. So now you can see that we are having like 2 states, the start and 5 cent state. It usually just have 2 states. Next thing you can do is that you can select your case structure, right click and say add case after to have the 10 cents and one more time to have the dispense. Now you can see we have all 4 states in our case structure. This is a default state of a state machine. Like whenever you want to build a state machine, you have to have these initial steps. You have to do these initial steps first, and then based on your program, you will add different things inside your case structure. So the way that this works is that it will start with a case with a state at first, and then come into the while loop and to the case to your case structure, and then depending on whatever state you are. So here initially it will go to start, because when we start, it will start with the start states, because nothing has been done yet. So then, depending on that, it will go to the proper case structure and a proper function happens to it. And then you will wire something into this case, into this shift register to the right, and the shift register a proper state actually, and the shift register carry that second state in the while loop, and now this is not our initial anymore, but the next state is our current. It's going to be our current state, and then it will come to the case structure again, and next time, for example, it will go to the next window, and so on. So depending on whatever that is happening, it will choose a proper state and carry the state with a shift register in a while loop. So let's go to the start state first. So when you are in the vending machine, there are 3 different ways, or actually 4 different ways that you can put your money inside the vending machine. You can add a nickel or dime, or you can just add a nickel, or you can just add a dime, or you can add a nickel and dime, because you're basically at 0.0 cents. So you have different ways that you can add your money, or you can add 2 dimes if you don't have a nickel and you don't care about your 5 cents. There is a function in LabView which is really useful for this kind of case, and that is called, if you go to the comparison, it is called the select function. Let's go to the help and see what it does. So this function returns the value wired to the T input or the F input. So you can see these two are like floating points number, and the S is green, is like a boolean. Depending on the value of S, if S is true, this function returns the value wired to T. If S is false, this function returns the value wired to F. So T and F are coming, and S is also coming. If S is true, the output is going to be S. Is going to be T. If S is false, the output is going to be F. So how can this be useful to us? Let's grab the nickel and the dime and bring them inside the while loop. So you can see nickel and dime, they are green, so they are true or false. This can either be nickel. If we click on the nickel, it's going to get true, and that means that we have inserted 5 cents in. And if we click on dime, then the dime is going to be true, and that means that we have inserted 10 cents in. If we don't click on nickel, or if we don't click on dime, it means that it's a false value and we haven't inserted anything. So because this is green, we have to wire to the S, to the middle one in here. So it says, so now if nickel is true, we are having 2 cases, the T case and then the F case. If nickel is true, that means we have inserted 5 cents in the vending machine. So how can we define that? You can copy and paste the case selector here and put it on 5 cents. So you will say, if nickel is true, that means I have inserted 5 cents in. Why? Because if S is true, it's going to carry the value of T. But if S is false, it means that no money has been put inside, or no nickel was inside. So what it means that I'm in the start stage. So I will just grab whatever that was in the start and connect it in here. So if I put 1 nickel in and the nickel is true, I will go to the 5 cent state. But if I don't click on the nickel, that means the value of the nickel is false, I will stay in the start state. That is exactly what it says. Let's do the same thing for the dime. But this time, the value of this first function is gonna be our F value here. Let me tell it in minutes. Why? Because now if we add the dime to the S, that means, did I add 10 cents? If the value is true, then you can copy and paste this case selector changed it to 10 cents. I mean, put it in the 10 cents function or state. So now if you add 1 dime, this is going to be true. And if this is true, this function returns the value of S, or 10 cents. So if you add 1 dime, it will take you to the 10 cent state. But if you don't add a dime, it will take you to whatever the result of this function is. It's going to be either a start or a nickel. If you have clicked on a nickel, it's going to show you the nickel. But if you haven't clicked on the nickel, it's going to show you the start. So assume that you haven't put any money in it yet. So these two are false. Both of them are false. So both values, so this is going to be false. So that means that the start is going to be shown here and the start going to be here. And because dime is false again, so the output of this function is going to be start. So if you don't add any money, you're still in the start state. But if you add 1 nickel, you will be in the 5 cent state. The output of this function is going to be 5 cents. Because you haven't added any dime yet, the dime is going to be false, and the output of this is going to be F, which is the nickel, or the 5 cents. So the overall output of these two functions is going to be a nickel. And if you don't add a nickel but just add a dime, this is going to be false. So you're going to be in the start stage, and the start stage is going to come here as your F. But because dime is true, when this is true, it's gonna the output of this function is gonna be the t value, or the 10 cents. So you will be in the 10 cents stage. But in the start section, you can either add a nickel or a dime, or you can add a nickel and a dime, right? You can do both of that. So there is another boolean called AND that we haven't used, I guess. We haven't used it in our previous videos. And that means, like, if X and Y are true, the X and Y is going to be true. And, you know, it's really simple. I'm sure all of you know, but if you go to the help, you can see what it means. If X and Y are true, it's going to be true. If either of them are not true, it's going to be false. And how can we use that? We can say, okay, if nickel is true, and dime is true also, then I can have another one of these functions. If both of them are true, I can have a t as a dispense. I can have the Coke dispensed to my client, right? So you can come over here and choose a dispense, and if both of them are true, it's gonna show you the dispense. But if either of them are not true, it's not gonna dispense. But what it's gonna do, it's gonna return the output of this function, because this is the last thing that happens. It can either be a start, a 5 cents, or a 10 cents. So now we have defined all three different ways that it can be. It can be 1 nickel, 1 dime, or a nickel and a dime. And the output of this function, it's going to be either a dispense, which is the t here, or the f here, which can either be a start, a 5 cent, or a 10 cents. And that has to be connected to the shift register on the right side. So then this shift register is going to carry whatever state that was final here into the shift register in the left, and then the start is going to the program is not it will not look at the start again, but it will look at whatever that carried in the shift register, and it will come inside. And then, for example, if it was a 5 cents, then it will go to the 5 cent stage. That's how it works. So if we are in the start stage, we know that we haven't added any money in it, so you can put the money inside a while loop. I will put it inside the while loop, but not inside the case structure, because I only need to see like one string indicator. But I'm going to create a constant for it, and I'm going to move the constant inside, and I'm going to call it 0. So if we are in the start state, that means that we have dispense 0. money. But when we go to the other states, we will dispense different monies. And then should the machine dispense you a Coke? No. So this LED here, it should be false. So I can create a constant again for it, and that constant right now is false. I can click on it and change it to true or false. But for this case, when we are in the start state, we are in the false state. That means that the machine shouldn't dispense any Coke for me. Now let's go to the next window, the next state actually, and that's a 5-cent state. So here now somehow the results of all of these things happen to be a 5 cents. So that means that now we have a 5 cents. We have 5 cents as our initial money in our system. So we should do the same thing. We should go and choose a select and say, okay, am I adding nickel? Yes. What is my initial state? It's whatever that is in here, which is my 5 cents. I have come to this page for a reason, and that's because a user inserted 5 cents in the vending machine. So now this shift register carries a 5 cents, and this is now a 5 cents, a 5 cent money. So if I add another nickel, so this is gonna be true again, and I can copy and paste this case selector. If I add another nickel, that means that I had 5 cents. I added another nickel, and now take me to the 10 cents state, right? But if I add if I add a dime, so I have a 5 cents, I have 5 cents, and now I'm adding a dime. Then I have 5 cents, I added a dime, then take me to what stage? The dispense stage. Because now I have added 15 cents overall. Again, like before, the value, the output of this function, which is either going to be a 5 cents or a 10 cents, is going to be the F value for this one. So if in the start stage, if I add 5 cents, so this will be true, and then the value of this will be 5 cents, and I haven't added any dime, so this will be false. So then this is 5 cents, and the results of this is also false because this is true and false, and then I'll be in the 5 cents. So then I'll come to the 5 cents state, and in the 5 cents, a user added another nickel. So I was in the 5 cents state, but the user added another nickel and make this true. So now I'm the 10 cents state, and that 10 cents state is here. If I don't click on a dime, so this is going to be false, and the result of this is going to be whatever that was in the F, which is 10 cents. But if I click another dime, if I add another dime, then 5 and 10 is going to be 15, and this is true, so we'll go to the dispense. So this will define your stage for you. There's also another way that if a user add another dime, like if a user add 2 dimes, but that's going to be on the next state, which is when you're at the 10 cents state. So I think I've explained this 5 cent state, and now again you can create a constant and say that this is a 5 cents, and again you can create a constant here and say that this is still false because we are still not in 15 cents money. Let's go to the next window or next state. In this state, a user somehow jumped to the 10 cents, either by adding 10 cents dime initially or by adding 2 5 cents nickel. But a user is now in this state because the shift register carried the 10 cents from previous situations. Again, you will choose this select function. So you are in a 10 cent state, and you have to always wire this to here because now we are in a 10 cent state. If a user add another nickel, you can copy and paste it here again. If a user add another nickel, then the machine, the vending machine, can go straight to the dispense section because now we have 10 and 5.50. There's also another situation, and that means that the user doesn't have another nickel, but it has another dime. Still, it's more than 15, so the Coke should come out, but there's no money coming out of the vending machine. So we'll do the same thing. We say that the user hasn't added any nickel, but if a user add a dime, what happens? Still do the dispense for the user. The user deserves it because they paid more than enough. So you still do that, and then you wire to the shift register, and if it goes to the dispense, if this is a dispense, then it will go to the dispense window. But here again, like before, we'll create a constant of 10 cents. So whenever we are in this window, we'll show it to the user that you have added 10 cents. And again, this constant is false. Still hasn't you haven't reached the money that is needed. Then eventually, when you are at the dispense, it will come here. You don't need to add more nickel and dime because you're already getting your Coke. It doesn't make sense that you keep adding money. So the only thing that you need to do is to create a constant here and say that, okay, you have reached the 15 cents limit, and should we dispense the code? True. Dispense the code. But notice that the stop button here for the while loop, it's still sitting here alone. So when should a while loop stop? It should stop when the Coke is dispensed. So when this value is true, the stop button can stop. But if this value is false, if we are in the different states, it's not going to stop, and the while loop still runs until you keep adding more nickel or more dime. So the program I've made the program, the state machine program, and it should be ready now. So let's save this program. I'm gonna save it with state machine vending. And oh, okay, there is an error. Okay, and that's it. If you remember when we were having these like hollow squares here, that means that we should either use default if wired, or if you don't want to do that, we have to wire this to here. So this shouldn't stay unwired. So what it means that when you're in the dispense section, just carry whatever it was which was dispensed, and it brought you to the dispense, and then get it out, and then leave the while loop because this while loop will stop. So you should either wire it or make it use it as default. Now let's run the program. So we are running it. I'm not touching any nickel or dime, so that's why the money that is inserted is 0 and there's no dispense. I'm going to turn on this. You can see that this is the start. You can see that this is false, so it will get me the start, and it will go back to start again, because this is false and this is false, so the false values will get out and they are all starts, and then I'm having nothing. But once I click on, for example, a nickel, this is going to get true, and then this is going to change to 5 cents. And it's going to take me to the 5 cents window. But it's going to stay at 5 cents unless I click on another button. So that's why you can see that it means that I have inserted 5 cents. So let's click on nickel again. Again, one more time when I clicked on the nickel, this is going to change to 10 cents. And this is going to go to the 10 cents window. And then this is going to switch to 10 cents. But if I don't click on anything else, it's just going to stay on 10 cents. Unless I click on another nickel. And then this will change to 15 cents, or it will go to the dispense window. And once in the dispense window, the dispense will be on and the while loop will finish. Let's run it one more time, but this time do it differently. This time, because the highlight is on, it's going to take a while for it to turn this off. This time I'm going to turn on, I'm going to click on the dime. So then this is going to get true, and this, the last state here is going to be a 10 cent state. And then I will have a 10 cents money in here. And now if I click on a nickel, from a 10 cents state, we're going to go to a dispense state because we have reached a 15 cents. And it's going to finish. There is also another way, and for me as a user, is to click on nickel first and then dime. So I just want to check all the different ways that we can run this program. Make sure that we haven't missed anything. It's really important for you to check everything, all the possible ways. So I'll add one nickel first. And again, because this is on, it's going to take a while. And then once I have the 5 cents value here, I can add another dime. Now I'm adding a dime. This is going to go to the dispense window, and we will have our Coke dispensed. There's also another way, and that's for a user to add 2 dimes. So let's check that too. I'm going to add 1 dime. I'm still keeping this highlight so you can follow how things change. Things are changing if you want to. So I've added 1 dime, and then I'm gonna add another dime, and this will go to dispense, and then you'll have your Coke. So yeah, so we have checked all the possible ways that it can happen. And the program looks okay and it's working fine. So this is called a state machine. So it really depends on, I'm going to turn this off. It really depends on the user and how the user is operating it. Assume that you haven't defined it this way. Your program if you haven't defined it this way, your program would have been so big, and you would have had several case structures inside each other, because you should have a lot of ands and ors and case structures, one inside and another. So you would have probably have maybe 3 or 4 case structures inside each other, and the program is going to get complicated and hard because you have to manually define everything. But with the case structure, the way that the case structure works, because of the while loop, the case structure here, and then the shift register, the way that the state machine work is that the state machine is going to define your different states with the help of a case structure and the shift register and a while loop. And then instead of having a ton of case structures inside one another, you can just have one but different layers of case structures. And then your program is gonna be, it will be easier to follow. The probability of you making a mistake is gonna become really low, and your life is gonna get easier. So whenever it's needed, use a state machine. Okay, I hope this video was useful for you guys. Till next video. See you soon. Bye.